Welcome to E Square Emporium, all things AP Psychology. Today we're going to be looking at statistics part 2. All right, so today we're going to look at how the data behaves in terms of variation. So everybody typically knows what a class average on a test is. So then how do all of the scores in the class revolve around that mean, that average? And there are various things we're going to look at today to see how this plays out. So we have measures of dispersion or variation, right? So you know about range, which is subtracting the highest score from the lowest score. And that's shown in this where you add them up, right? 8 minus 2, high score minus low score equals 6. Then we get into this variation with the range around this mean. Then we get into something that can throw out all of what we think is that middle, known as outliers, right? So outliers skew results. So in this case, on the picture, if you see the family income of $710,000, that's going to alter the mean, which is the average, and all of a sudden send faulty signals that all the people in the middle are making so much more money than they really are. And we want to get rid of that when we have accurate data. All right, so standard deviation. Don't let this scare you. This is really, at this point in the game, is really just knowing 6 score sets. All right, so we get a mean. You know how to calculate the mean. You add up all your scores, divide by the total number of scores, and you get that number. That's what would go into the middle of this graph known as your bell curve. The bell curve, by the way, is considered to be ideal. It rarely, if ever, happens. There's always some kind of difference from these idealistic numbers, but this gives us a base, a reference point. All right, so it goes something like this. Off the mean, we have a standard deviation number that is calculated, and you don't have to do that in this class. We're going to give you that number. So whatever that number may be, okay, that's going to be how many numerical values are located to the right in the positive first unit of standard deviation. It'll be the exact same number that you use for the second unit of standard deviation, and the exact same number for the third, and then the same applies to the left. All right, also looking at this chart, you realize that in the middle, 234s are going to equal 68%. The two 13.5s on the left and the right added together make 27%. So we have 68 plus 27, we're now at 95. And then we have the 2.35s, which gives us 4.7. So now when you add all of these up, all 6 units of standard deviation equal 99.7% of all the values. Why is it not 100? Because we have to account for the outliers. Okay, so what are the properties of the normal curve? And that's what I just went over. So if you take a look in the middle here, what we show is that there's a standard deviation of 15 points, which again is a given. You don't have to calculate that. We're going to give you that number. So there are 15 IQ points in this example that allow us to look at standard deviations. So the average, the mean, is 100. Okay, that is mental age over chronological age times 100 equals 1. So that's how we get to the 100 being in the mean, or being the mean. Now we come up by 15 points because that is already given, and then another 15, and then another 15, which is what I meant on the last slide. Whatever your standard deviation amount is, it's always going to be the same in terms of movement. Okay, so we take 15 points, add them to the 100, that gives us 115. And within that range of 15 points, from 100 to 115 IQ points, what we're saying is that represents 34% of our population. Go to the other side where we take 15 points and subtract them. So now we go from 100 down to 85. And what we say is that 34% of the population falls into that range of scores. So that means if you have a 90 IQ, you would fall into the group that makes up that 34% of the population, and so forth and so on. Okay, so we have, as you see on the bottom, a positive standard deviation of +1 SD standard deviation to the right. Then the second unit is +2, and the third unit is +3. Going to the left, the first unit is -1 standard deviation, -2 standard deviations, and then -3 standard deviations. Okay, so let's say that we have a standard deviation of 10, right? So the first unit of standard deviation on the plus side, so +1 SD, will be 10 points if that's what we're saying is the standard deviation. And then another 10 is 13.6, another 10 is 2.3, and vice versa on the other side. And so back to the IQ. So we have a mean of 100. 115 is, that would be +1 SD, goes from 100 to 115. That's 15 IQ points, and at the same time represents 34% of the population. And on the left, it is -1 SD, or the negative first unit of standard deviation, and that represents IQ scores from 100 down to 85, and makes up 34% of the population. And then you do the same thing going from 115 to 130 and 130 to 145. Again, you might ask, well, what happens when somebody has an IQ of 220? Well, that's the outlier. That's why it's 99.7. We account for extreme scores that way. Okay, again, another viewpoint of this. So if I were to say to you that what percentage of the population makes up the second unit of standard deviation? Well, now you go to the 100. 100 to 115 is the first unit. 115 to 130 is the second unit. And then we look up and it makes up 13.5%. All right, here's another example. What if I were to say to you, what standard deviation unit does having a 61 IQ fall into? Well, now you go to the bottom and you go, okay, where does 61 fall? Oh, it's between 55 and 70. Oh, that is my -3rd standard deviation unit, which makes up it'll be 2.35% of the population. All right, here's an example with a pine tree. The standard deviation is 30 centimeters. So each line represents the plus or the minus of the 30%. So 150 is your mean, and then you just add 30, so to 180, 210, 240. Again, that is your first, second, third positive standard deviation set. And 120, 90, 60 is your -1, -2, and -3 standard deviation set. All right, so it's your turn, right? So if the mean on the test is 79, what is the standard deviation? All right, you can pause this and play around with this yourself. Right? Answer would be that you take the 100 and you subtract the 79. So that gives us 21. You divide that by 3, so then your standard deviation is going to be 7 points. And if that's the mean at 79, then we have +7, +7, +7. And you can put that onto a curve. Okay, next we get into skewed data, what we call the extreme skews, extreme scores, which make up a negative skew, a positive skew, and those are what are known as the tails. If it's double-tailed, we simply mean that there are extreme scores on both sides. If it's single-tailed, then there's either a really extreme negative score or an extreme positive skew, which, if you look at the right graph, tells us negative skew, positive skew. Okay, again, so the top left graph shows us that we have a right skew. The extreme score is positive, it's to the right. And on the top right graph, the left skewed example, the tail is to the left, so it's a left skew. And you can work that out with the animals on the bottom. Here's another example of this. Okay, the tail of the kangaroo. So you see where the mean sits, and then you have extreme scores. This is why in some classes a teacher will, by curving a test, simply, let's say, kick out the top one or two scores, and then make, let's say you got, the kid who got 100, another one who got a 99, and then the next score is a 95 on down. They may kick the top two scores out, and that 95 is equal to 100% basically, with the other two scores getting extra credit. That's one way of doing this in terms of how to score, and curve a test. Here's the negative side of this. Okay, tail to the left. Okay, so now comes interesting question. Which class test would you rather take? Would you rather have a test where you have a negative skew, or a test where you have a positive skew in the results? So, if you walk in and your last period of the day and you ask the teacher, hey, what are the test scores like? And they say, well, it's positively skewed. Would you want that as your test? Okay, so in this case, if you take a look, the mode, or the high frequency of scores on the left side, on the positive skew, sits to the left of the mean. Okay, that means that a whole bunch of kids didn't do so well. And then on the negative skew, a whole bunch of kids did really well because they did better than the mean. Right, so you can see that sometimes negative is the right way to go. That's it for now.